What's good? What's good? So I'm about to figure out. So I got this Xcode, the the support for iOS and iPhone stuff is downloading right now. But I want to build a mobile app, and I don't know Swift. I've got like a tiny bit of experience with Xcode, so I'm gonna take this course. I don't know if I'm shooting myself in the foot by jumping straight into this. It says it's beginner. I have this open in another tab just in case I need to learn the basics, but I mean, I should be good, I hope. So I'm just going to jump right into build iOS apps with Swift UI, get into it, start with iOS and Swift foundations, then wireframing and creating a project in Xcode. By the end of it, I'll build a simple iPhone app. So, welcome to iOS development with Swift. Embark on a journey through Codecademy's first ever iOS skill path. Welcome to the introduction to iOS development with Swift skill path. If you've ever wondered how mobile applications are built for Apple devices like the iPhone or iPad, you've come to the right place. In this skill path, you'll explore the fundamentals of the Swift programming language, the Xcode development environment, and learn everything you need to know to build an iOS application from start to finish. Let's take a closer look at what's ahead. Learn or review the basics of Swift. You will apply your knowledge of the Swift programming language to build a trivia game iOS application. Don't know Swift yet? We've got you covered. We'll teach you all of the Swift concepts you'll need to know to jump right into app development. Lessons from our Learn Swift course will help you develop your knowledge of programming fundamentals and empower you to quickly pick up other programming languages in the future. Get started with Xcode. We'll also add a powerful new tool to your tool belt, Xcode. This is the development environment required for designing and developing iOS applications. You will write Swift code and build your application's user interface in Xcode entirely from scratch. Much like the structure of any smartphone device application, the app you build in the skill path will have images, buttons, text, and various other interactive components. Master iOS development fundamentals. Another major technology you'll master is the Swift UI, Apple's latest innovative framework used to design and structure an app's user interface. Additionally, you will learn and put into practice a popular iOS app architecture, Model View View Model, MVVM, in order to establish how certain parts of your app interact with one another. Use your new skills to create a fully functional iOS app. As you acquire these new skills, you will apply your knowledge to building a fully functional iOS application bit by bit. You will then be able to run this application on a simulator and interact with all of its features. Here's a preview of the app you'll build. So, what was iOS originally called? And you get to select things. Publish your app to the Apple Store, optional. We understand that building a mobile application to have it live solely on a simulator is not much fun. By the end of this skill path, you'll be able to share your application with the world by publishing it to Apple's App Store. We'll teach you how to take your creation from the bounds of your own computer and make it part of the iOS ecosystem of apps that users interact with on a daily basis. We leave you with these words before you start your journey. Let's go invent tomorrow instead of worrying about what happened yesterday. Steve Jobs. It's a good quote. Introduction to iOS. Get a brief introduction to the world of iOS and what makes it an ideal choice for mobile development. What is iOS? On January 9th, 2007, Steve Jobs, then CEO of Apple, introduced the first generation iPhone to the world. On this new device came a robust operating system, iOS, formerly iPhone OS. Since then, Apple has grown iOS to be one of the most well-supported and feature-rich platforms on the market. Devices like the iPhone and iPad have redefined mobile development. Today, iOS is the world's second most widely installed operating system. One major reason why people choose iOS is because of its strong set of privacy features, many of which exceed its smartphone operating system rivals. iOS includes a sandbox that isolates programs, which is not done by any of its competitors, making it harder for malicious actors to access information. Additionally, it has a rigorous, regular review process performed on its software, especially its open source components. iOS development with Swift and Objective-C are the two main programming languages that Apple offers to build iOS applications. Objective-C was the primary language used for iOS development prior to the release of Swift. In 2014, Apple introduced Swift as the simpler, more modern alternative to Objective-C in the world of iOS development. With its comprehensive language documentation and vibrant open source community, Swift has become one of the most appealing languages for both beginners and experienced developers. It's no surprise that Lyft chose to rewrite their entire Objective-C mobile application from scratch to run on Swift in 2015. Device fragmentation and testing. Swift's success is just one reason why developers choose to build their mobile applications with iOS. Its device fragmentation is another. Take a second and think through what devices support iOS. Different iPhone models might come to mind. Now try to think about all the phones that support Android. They're countless. This wide variety of phone types is called device fragmentation. Because iOS has low device fragmentation, iOS applications can run successfully on all Apple devices with less testing. Highly detailed design guidelines. Another major factor that aids in shorter development time for iOS applications is Apple's highly detailed human interface guidelines. These guidelines include style rules that iOS developers should follow when building their applications. The benefit to them lies in developers are able to spend more time and effort building applications and less time designing them. Design is better and more consistent across all iOS applications. iOS applications on the App Store. In addition to iOS development being a quick and efficient process, developers also favor the Apple ecosystem because of the App Store. Apple users are more likely to purchase an app or pay for in-app purchases. Thus, iOS applications listed on the App Store generate a higher revenue than apps on the Android Play Store. So while Google Play has more app downloads overall, Apple users are more likely to spend money to improve their app experience. So, cool. I'm not even making something to sell, honestly. I'm making something for myself. Introduction to Swift. Swift is a powerful and intuitive general-purpose programming language developed by Apple. Its development started in July 2010. Much of the inspiration for Swift came from languages like Objective-C, Rust, Haskell, Ruby, Python, C#, and many others. Swift's concise yet expressive syntax and modern features make it the perfect first language for beginners and one experienced developers enjoy transitioning into. Its first version was released in 2014 with the intent to create applications for iOS, watchOS, macOS, tvOS, and Linux. Since then, hundreds of companies, including Uber and Slack, have incorporated Swift into their tech stack. In this lesson, we'll start by learning the basic concepts and fundamentals of Swift. Happy coding. Can you spot any other companies in the GIF that use Swift? A bunch of them. Hello world. Take a look at the hello.swift file in the code editor that is placed in the middle of the screen. It's a Swift program. When learning a new language, tradition suggests that our first program prints to the screen, hello world. In Swift, this can be done in a single line, print hello world. Everything inside the double quotes will be printed to the terminal. The terminal is a window that allows people to interact with the computer program. The terminal is the black panel on the right. Got you. Press run. We learned how to output a line of text with the following code. It will output that. You can also output multiple lines. So instead of displaying those two lines in the code, edit the code so that we output the following pattern in the terminal. Okay, so comments. Got you. Create a single line comment followed by your favorite emoji. I'm not on my phone. How am I supposed to put an emoji in there? I guess I'll just see if can I get away with that. Oh. Okay, cool. Before we move on, let's write a letter to your future self. In letter.swift, let's add the following goals for yourself, name and date. Dear self, make an awesome app. Name and date. I have the date right? No, I don't. Cool. What would the output be for a program like this? That's a trick question. I guess it's not. I just didn't really look. Okay, which one is a single line comment in Swift? True or false? Swift is a general purpose programming language that can be used to develop applications. For those things, it's true. What should go in the blank to output a string in the terminal? Block letters. Write a Swift program called initials.swift. Displays the initials of your name in block letters. Don't make me do this. I hate this. They made me do this for the Python fundamentals, and this is just, it's just not fun, you know? So, it's just, it's more effort than it's worth, is how I feel. Especially when it does annoying stuff like that. But I'll trust the process, I guess. I guess I have no option. This is another thing. A, B, C, D, E, F, G. They messed up on the G. Looks like a 6. Let's see if they'll let me get away with that. Take a look at the complete alphabet and find your initials. Oh, okay, I don't really have to do it. Cool. Okay, cool. I'm glad they didn't really make me do all that. What is an IDE? Okay. So, do I have to read this? I'm gonna speed read it. In Swift, the func keyword denotes a function which is followed by a name. An IDE would have a different color for a function. Swift is a compiled language, which means that code is translated directly into machine code. In comparison, interpreted languages are those that are executed line by interpreters. Compiled languages are usually faster than interpreted languages. A .swift file could be converted into an executable using the swift C command. However, for projects containing several Swift files, it is advisable to use an IDE to compile and build these files together. Build processes are built right into IDEs, so developers don't have to perform any extra setup for compiling and executing code. Just like you didn't have to worry about code execution in those lessons, debugging code is rarely ever perfect. Now that we familiarize ourselves with the power of IDEs, you might be wondering which IDEs are out there. iOS applications are typically built using XCode, which can be downloaded from the Mac App Store for free. The latest version is there. There are other IDEs like AppCode, but since XCode is with Xcode, you can either choose to build and run your app on a simulator or directly on your iOS device. Several simulators can be configured on Xcode, spanning different iOS versions. Once you're done with coding your app, you can build an executable using Xcode and upload it to the App Store. Cool. installing and setting up Xcode. In this article, we'll discuss how to install and set it up. So I actually read a version of this article just before I started this stream, so I have this all set. What is Swift UI? Learn about Apple's modern, innovative framework used to build user interfaces and how it compares to UIKit. An iOS application consists of a user interface and the code that powers it. In this article, we'll learn about Swift UI, a software framework that is used to build user interfaces, UI for iOS apps. We'll explore why it's an ideal choice for iOS development in comparison to its predecessor, UIKit. If you're a beginner in iOS development, you might be wondering what the difference is between Swift and Swift UI given the similar terminology. Swift is the general-purpose programming language used to build apps for iOS, iPadOS, macOS, watchOS, and tvOS. It controls the behavior of an application through a series of tasks written in code. Swift UI, on the other hand, is a set of tools used to build user interfaces. You can write Swift code to define where a button should be shown or an image should appear, and it is then left to Swift UI to make that button appear or load the image. Again, you write Swift code to define where a button should be shown or an image should appear, and it's left to Swift UI to make that button appear or load the image. Swift UI was introduced in 2019 at the Worldwide Developers Conference, an annual event for developers where Apple debuts major features. If you're interested in watching the launch video, which I'm not, Swift UI versus UIKit, before 2019, iOS developers built the UI of their iOS apps using UIKit. UIKit is an Apple framework used to manage all of the UI components in iOS apps, from screens to buttons, labels, and more. In comparison to UIKit, Swift UI is a major improvement, with its code significantly shorter and cleaner, and its features more modern and intuitive programming approaches. Apps built using UIKit follow the imperative programming approach that focuses on how a program should operate by specifying a set of commands. This is different from the declarative programming approach used by Swift UI, where the handling of different scenarios is focused on the outcome of the problem and not on individual commands required to solve the problem. Declarative approaches have gained popularity over time as they require less code and are easier to optimize. So imperative versus declarative programming. Looks like developers paying a bunch of money or has a bunch of stuff to give to the compiler. That's imperative. Whereas declarative, the developer has just a few things to give to the compiler. On the imperative side, we see the developer saying, the stack of papers on your right will tell you in great detail how to iterate from the first to last paper in the array of papers on the left in order to iterate again over each string in each paper and push every string into a new array of papers. And the compiler is like, okay. And then on the declarative side, the person, which I'm guessing is supposed to be the developer, or this is the compiler? Yeah, no, this is the developer. They didn't write the name on the shirt. Here's some papers that I'd like to clone. It's completely up to you how you do it. Thank you. And the compiler is like, okay, build duration 10.6 seconds. Declarative programming may be slower compared to imperative programming. Code preview, a modern feature of Swift UI that many developers enjoy, is the live preview of their code and its ability to automatically display updates as you make changes to your code. With UIKit, the iOS application would need to be built and ran every time you make a single change in your UI code for it to reflect on the screen. For larger apps, this is a major inconvenience because build times may be longer. Layouts and code comparison. In comparison to Swift UI, apps built using UIKit have a more complex system in place when it comes to building layouts. As you'll see more later in this path, the user interface and functionality for a single screen of a Swift UI app is developed in one place. Say your user interface contains a button, that button would be created and its click functionality would be set up in a single .swift file. With UIKit, this is not the case. Again, in comparison to Swift UI, apps built using UIKit have a more complex system in place when it comes to building layouts. As you'll see more later in this path, the user interface and functionality for a single screen of a Swift UI app is developed in one place. Say your user interface contains a button, that button would be created and its click functionality would be set up in a single .swift file. With UIKit, that's not the case. iOS developers would have to deal with interface builder files and storyboards to set up the user interface and separate Swift files for the functionality for that interface. The same button would no longer live in a single file but across multiple, and its management less efficient. With shorter, more concise code and fewer files, Swift UI apps are faster and easier to build than UIKit apps. Take a look at the following sample app. we've created one version of this app that utilizes Swift UI and another that utilizes UIKit. View each one in our Build iOS application with Swift GitHub repository to see a general difference in structure and content. So let's check it out. First, let's check out the, the Swift UI version. And then this is the UI kit. So already, it's looking a little lighter, right? That's good. Test app Swift. So import Swift UI, app main, struct, test app is an app. Var body, some scene, window group, content view. Whereas with UI kit, well, I guess it's not exactly the same. So XML version 1.0, encoding UTF-8, doc type, playlist, plist, dict, the key string. Content view, import Swift UI, struct restaurant is an identifiable, ID, name, subtext, address, status, restaurant row. Some styling, it looks like. Versus I mean, they don't look too different, honestly. Regardless, using Swift UI, the layout of this app can be built within a single file titled contentview.swift in less than 50 lines of code. In order to build the same interface and functionality with UIKit, we require the combination of the following files: viewcontroller.swift, main.storyboard. I see, I didn't really check out what was in those folders. Regardless, wrap up. Great work on getting to the end of the article. Cool. On to the next one. What is wireframing? Learn how to build a wireframe for a website or app and why this is an important step in app development. Before we build something, it's a good idea to make a plan for what we're going to build. For example, if we're building a house, we shouldn't do it without planning with designs and blueprints. When developers make plans for apps and websites, they often use wireframes. A wireframe is a collection of sketches and notes that depict a website as it would look on a browser, a tablet, or a mobile device. It shows the layout of the app's elements, like navigation bars, buttons, content placement, and more. It's like the blueprint to our app. Here we'll be focusing on hand-drawn wireframes without too much detail. These are sometimes called low-fidelity wireframes. The wireframe outlines the purpose of the app's pages or screens, answering questions like, what is the user trying to get done when they see this page? It also summarizes the relationships between different parts of the app and the results of interacting with the app's elements, answering questions like, what happens when the user clicks this button? With good designs and blueprints, an architect can help others envision living in a house that has yet to be built. And with a good wireframe, we will be able to show other people what our app does in considerable detail, all without writing a single line of code. Like architecture, successful wireframing relies on the marriage of product design skills with technical understanding. So take a moment to get in touch with our artistic side and brush up a bit on our knowledge of the app's platform's limitations. Then we'll get started wireframing. But first, a word of advice. As learning developers, we rarely know what is or is not possible to achieve on our target platform. When this is the case, there's no harm in looking at popular applications for inspiration. Good artist copy, great artist steal. The Code Academy content development team. Screens, rooms. The first step of wireframing is to list our application screens. In app development, a screen is a self-contained user interface devoted to a particular purpose within the application. Individual web pages are the screens for a complicated website like Amazon.com. Think of how the shopping cart and past orders are shown on separate self-contained pages. Similarly, a smartphone's clock application generally has separate screens for the current time and for setting alarms. Designing an app screens is like the first step in designing a house. The house is divided into rooms, and the app is divided into screens. House and app designers must weigh similar considerations. For example, modern homes typically limit themselves to one kitchen. A single family home with 2 kitchens would be cumbersome. Blah, blah, blah. Likewise, a shopping site with 2 checkout pages, quick checkout and checkout, will probably confuse its users. Another home design mistake is failing to differentiate between rooms. In a small studio apartment, the cooking, sleeping, and living areas all tend to interfere with each other. Generally, people prefer to have separate rooms for these separate activities. It is similar for screens in the world of software. A good example is the story of how Adobe Photoshop gradually outgrew its living arrangements by adding features unrelated to photography. The developers tried to include print design, website design, custom typography, and more, all on the same screen. Later, Adobe shifted from the single license / single tool model by introducing Illustrator, InDesign, XD, and other software. Now, not only are the different functions of the old Photoshop found on different screens, they are in different applications. Before we design our app screens, we need to look at the big picture, the purpose of our application. Does the app home need a single screen, room? Maybe it needs 3, 10. What features does each screen implement? Make sure not to include too many features. Not every house needs a swimming pool, and not every app needs to be a social network. Do the screens have well differentiated purposes, or are they cramped like a studio apartment? Now that we have a game plan, let's get to work. If you'd like, follow along with these steps envisioning any app, real or imagined, that sets your heart ablaze. Let's make a list of our app's screens and the purposes served by each. So I'll make a little blueprint for the app I plan to make, which is a AI voice chat app. So let's make this a little bit bigger. For right now, I'll call it AI voice chat app, and we'll say we need, I'm gonna do this in Markdown. So we'll say we need a conversation screen, or you know what I'll do? I'll call it a talk screen and a chat history screen. Maybe might want a settings screen too. Cool. I think that's it for right now. And I'll say on the talk screen, we want to, a button to record speech. We want to send, or we'll say, I don't know how granular it wants me to get, but I'll say convert speech to text, request model response from server, return text from return text response, convert text to speech, here AI response. That's what we want on the talk screen. On the chat history screen, we just want a list of old conversations. Clickable to re-enter conversations. And on the settings screen, we might want to be able to change, I don't know if I want to change the voice, maybe change color, I don't know, etc. I'll say. So a flow is the path a user takes through a piece of software. The flow models a typical user, predicting which screens they will need to visit and in which order. The point of considering flows is to make common chains of activities easier to accomplish for our app's users. As an example, take a brand new user visiting a web application through its homepage. Afterward, they will usually need to create an account on the account creation page. Finally, you know what, maybe it would be cool in the settings screen, you could change, you could say persona, right? Because you might want like a therapist bot, or you might want a friend bot, or a mentor bot, things like that. And so flow is a path. It's a path the user takes through a piece of software. The flow models a typical user, predicting which screens they will need to visit and in which order. The point of considering flows is to make common chains of activities easier to accomplish for our app's users. As an example, take a brand new user visiting a web application through its homepage. Afterward, they will usually need to create an account on the account creation page. Finally, they should be redirected to the application's main page. Imagine the annoyance if this chain was broken at any point. If there was no link to account creation from the homepage, the new user could give. Sorry, I lost my focus. Imagine the annoyance if this chain was broken at any point. If there was no link to account creation from the homepage, the new user could give up on joining the site. If the account creation page didn't link, or better yet, automatically redirect to the main page, the user would have to manually reload the homepage. Not very considerate of the developers. So developers thinking about user flows through software is like an architect thinking about the lifestyle of the people who will inhabit their house in development. Usually people don't want to enter a home through the bedroom or to pass through the bathroom on the way to the kitchen. Of course, people's lifestyles differ. We won't judge. But that would actually be really trippy. Imagine you go in somebody's house and like you're in the bathroom or their bedroom, you know, just something out of the ordinary. It would be kind of really, I mean, it sounds really inconvenient, but it would be trippy. Thinking about where was I though? Almost nobody likes being in a room without exits, the equivalent of the web page with no links. Thinking about user flows, lifestyles. Take each screen from the previous step and define one or more entry and exit pathways. Entry pathways may be external to our application, directly from the web, from a shared URL, from an app icon on the device, but often they come from other screens within our software, e.g. in a magazine app. The user may enter the read article screen from the article list screen. So here we could see, direct, organic, PPL marketing. I'll take you to this home screen, which will show you the latest products, offer discount incentives, quick login, product search. From here, you can go to search, you can go to promo and get product details. You can add to cart, search screen, search results, feature product surfaced, filter results, also get you to product details, and you can add it to cart, and from cart you can view a product, and you can also get to product details from social, organic, or PPL marketing. So I'm, again, not too, this is for personal use really. Just so I can make this smaller, I'm just going to delete that for right now and then condense that a little bit. But yeah, so I'm not too worried about like getting here. So I guess I'll just add direct, and I'll add a points to how am I going to do this? Let's do it like this. And you get there from the talk screen. Or you could get to the chat history screen from the settings screen. And from the chat history screen, you can, we'll just do it like this. You can go there, or here's how I'll do it. So the chat history screen is kind of like the main nav bar, I guess, or like, you know, how you're getting around. And the settings screen, yeah, I guess you're gonna get here from the chat history screen. And from the settings screen, you can also go to chat history. Cool. So, and this is saying, cool. So wireframes, blueprints. The third step of wireframing is to actually make the wireframes. Recall that wireframes are sketches of our app's screens in rough approximation to how they will appear in the final product. But while wireframes may be rough in terms of appearance, in terms of concepts, they are fairly precise. Just like an architect can visualize a finished house by looking at a blueprint, another app developer should be able to use our final wireframes to understand exactly how our app's UI is organized. This is serious progress. Before this step, our app consisted of vague ideas and promises. When the step is complete, our app will have concrete features and a visual layout. Everything short of actually working. So grab a pen and some grid paper or use a convenient drawing app. And let's get drawing. To begin, pick a single screen and draw a box representing its approximate aspect. So I guess I'll come into Figma and I'll just make this for real. New design file. I'll call it AI. Goodness. And make a frame, phone. Does it matter? No, it doesn't. I guess I'll do this. It's really vertical. So what am I doing? I need to make which page am I making? I guess the chat history screen is the most, it's like the center piece. So we'll call this chat history. And I guess we'll want some boxes like this. And we'll do a stroke. And in all of these, we'll get rid of the fill. And so the idea, have a bunch of chats and maybe there should be something like chat 1. This big. I'm gonna make it Montserrat. It's my favorite font. And do it like that. Here's what I'm gonna do. I'm gonna delete all these. Oh no, I messed up. Where's this? Group these. Nice. Cool. And I'll just kind of center these. Cool. And then maybe we'll want like I don't know, where should the settings? If I'm on my phone, right? What do I want? Like new chat. I guess I'll put the new chat down there and I'll put the settings button at the top. Something like that. And talk. And I'm kind of just going to bite the way that the ChatGPT talk setting looks. It's like a big circle. How does it look actually? This is not me learning Swift. This is kind of feels like procrastination at this point, but whatever. Okay, that's how it looks. So it's like kind of like that. These are kind of small though. That's fine for now. We'll you know, do talk voice, and we'll do talk text. And we'll have the keyboard. And we'll have, the chats. You get the point. And then for the settings, just delete all of that. And we'll have it, how do they do it? So it's like, I don't really care about most of this stuff. Yeah, just some boxes to fill out some different information. And we'll just say for now, section 1. Section 2. Good enough for now. Let's get back to, there was an error. I never saw that before. Are we good? Is this going? Looks like it. So back here, single screen Dropbox, designing web app. Keep in mind that not all our users will have their browser in full screen mode, so might need multiple versions. Smartphone displays are in portrait mode and range from 16.9 to around 2.1. Make sure the boxes are large enough to fit lots of features and notes. Now we will fill in the UI for each screen, making sure it satisfies the requirements we wrote down in step 1. Let's see how this might be done using our familiar example. When we log into codecademy.com, the first thing we see is the dashboard. The purpose of the dashboard is to help the user perform their next action on the site, be it taking a lesson, working on a project, or reviewing concepts. The dashboard is a screen like the ones we've been working with in steps 1 and 2. Here's how the dashboard might have been conceived as a wireframe. The wireframe anticipates, okay, blah, blah, blah. Don't worry, we don't have to be great artists. Circle, box, rectangle. It's amazing how we can exercise our design aesthetics using such simple symbols. Just don't forget to write notes about what the shapes mean. It might not be clear to others or our future selves that this circle represents an avatar, blah. At this point, our heads are in the clouds contemplating all the wonderful blah, blah, blah. This is where a technical understanding of our development platform can bring us down to earth a bit. Wireframes specify everything an app will do without explaining how we'll do it. This is similar to how blueprints, blah. We don't need to be running a computationally-intensive VR game in the browser using JavaScript, just like how we couldn't support an entire wing of a house on a single column. How do we know if we've created successful wireframes? How does an architect know their house design is good? The decision is aesthetic in the same way. While app design is a computer science, it's also an art. There is no formula for wireframing the perfect user experience. Luckily, one becomes a great artist and a great scientist in the same way. Experimentation. Let's return to the Codecademy dashboard. The dashboard helps learners blah. The alternative wireframe features suggested courses front and center. Unlike the real dashboard, is this a good idea? The dashboard wireframe emphasizes the completion percentage of the user's current course. Does this work to motivate the user to jump back into learning, or does it intimidate them? The ordering of the UI elements is different in this dashboard wireframe. Which order is best? UI design is a tricky business. In our apps wireframes, okay. Okay, I get it. For making a static web page, we may use HTML and CSS. If it's a dynamic web app, we might check out JavaScript and Node.js, or for planning a smartphone app, we might consider Swift and Xcode. So cool. Wireframing the code history trivia game. No. I don't want a wireframe. I want a code. Introduction to variables. The Hello World program simply writes to the screen. It does not read anything, calculate anything, or allow for user input. That's no fun. Real programs tend to produce results based on some input that the user or of the program gives, rather than just outputting the same thing every time. Our first computer to produce something meaningful. For our computer to produce something meaningful, we first need somewhere in the computer's memory to store data. That is where variables come in. A variable is simply a name that represents a particular piece of your computer's memory that has been set aside for you to store, retrieve, and use data. In this lesson, we will learn about variables and constants, as well as some of the basic data types: int, double, string, bool. Every variable has a type, which represents the kind of information you can store inside it. It tells your compiler how much memory to set aside for the variable and defines what you can do with the variable. Cool. Declare a variable. What do you want me to do? Declare a variable named year, the value of the current year. Oh yeah, this is in Python. Output a year using print. Arithmetic operators. Computers are incredible at doing calculations. Now that we have declared variables, hold on, let me just make this full screen. We have declared variables. Let's use them with arithmetic operators to calculate things. Here's some arithmetic operators. Cool. In the code editor, we've already declared initialized variable amount. Declare a new variable named tip. Give it the value of amount. Now print out tip. Cool. Compound assignment operators. Sometimes the value of the variable needs to be adjusted. And we can update our variables using that. Also have the option to use compound assignment operators, shorthand method for modifying the value. Imagine being the owner of a small fruit stand. To start the day, there are 16 apples in the inventory. Suppose a customer comes in and buys 4 apples. Use a compound assignment operator to adjust the value of apples. So apples minus equals 2. I'm not paying attention. They bought 4. Another customer purchases half of the available apples. Underneath the previous code, change the value of apples to reflect this exchange using a compound assignment operator. Type. We can provide a type annotation when we declare a variable to be clear about what kind of value that the variable can store. Some of the basic data types: int, double, string, bool. Type annotations begin with a colon and end with a type. To declare a variable named artist and give it the type string, you do var artist colon string. It explicitly specifies the type of a variable to be string. So now we can only give artist text string values. We can also write the above code in one line. Swift is known as a strongly typed language. If you try to give an integer variable a decimal value, you're going to get unexpected results, warnings, or errors. Declare a string variable named book. String interpolation. Oftentimes we find ourselves needing to insert values into a string. In these cases, we can use string interpolation. In Swift, to insert a value into a string using string interpolation, we can write the value in parentheses and write a backslash before the parentheses. For example, var albums equals 17, print Daniel Johnston made backslash parentheses albums, studio albums. I'll output that inside string.swift, declare a variable called age. With age setup, I use print and string interpolation. So we're going to print I am age years old. Cool. Constants. We've manipulated variables in the last few exercises, but what about variables with values we don't want to change? That's the job for constants. Whereas variables can be reassigned during their lifetime, constants cannot. Once we assign a value to a constant in Swift, it becomes immutable. This means that the value stored in it cannot be changed. In Swift, constants are declared using the let keyword, so be like let pi equals that. Why do we use constants? Primarily, constants are used as a safety measure. By using constants, we are making sure our programs safer by guaranteeing that we only change the values we expect to, and thus prevents some potential bugs. Declare a constant named months, so let months. Assign it to the number of months that end with y. Why are you making me do that? Is that every month? January, February, March. So April, May, that's 3. June, July, that's 4. August, September, October, November, December. I said, is that awful? It's funny. Challenge, temperature. Now that we've learned about the basics of variables and arithmetic operators, let's write a program. The mad scientist Kelvin has mastered predicting the weather in his mountainside meteorology lab. Recently, Kelvin began publishing his weather forecasts on his website. However, there's a problem. All of his forecasts describe the temperature in Fahrenheit degrees. Let's convert a temperature from Fahrenheit to Celsius. Formula is the following. C equals F minus 32 divided by 1.8. First, search for the current temperature of New York City in Fahrenheit. Declare a double. So maybe I'll actually search for it. Whatever, it doesn't matter. Let's say it's 42. Oh yeah, it's a double. Oh. Convert the temperature to Celsius using the formula provided. Store the result in temp C. Display the result using string interpolation. So damn. It's a lot of fives. You made it. Cool. Optional, the body mass index is commonly used by health and nutrition professionals. It's fine. You don't need to do that. It's fine. I'm trying to build something. I thought it was optional. Okay, cool. What is the correct way to declare an integer named age? So you can have var age colon int. What would the output be for this piece of code? Var player level equals 0. Player level equals 3 plus 4. So you're reassigning the value. Player level is 7. What would the output be for this piece of code? Var dumpling is an int equals 5. Dumpling plus equals 3, so now it's 8. Dumpling divided by equals 4, so now it's 2. In this declaration and initialization, what is the variable name? Year. What are variables used for in Swift? For storing data. What value will be stored in the variable division? 24 divided by 8 is 3. What is the data type of X? It's a Boolean. Let's build the app. Come on. I guess this is necessary to learn. The quadratic formula in algebra, a quadratic equation is an equation having the formula ax squared plus bx plus c equals 0. Graphing the quadratic equation will create a parabola like the one below. The corresponding x values are the x-intercepts of the graph, while a, b, and c are constants. Write a Swift program in quadratic.swift that solves the quadratic equation for the x's. So first things first, to declare 3 variables, we'll use to store decimal numbers. So var a, let's take a time machine to algebra class and solve for the quadratic equation. So solving for quadratic formula problem means figuring out what x is. It's also possible for x to have 2 values, also known as roots. Let's get 2 more double variables to store these roots. So var root 1 for root number 1, var root 2, so double. For root 1, the equation has a plus sign. The overall equation can be broken down. First, focus on solving for b squared minus 4ac. So now we use the value for root 1 and solve for the square root of that. This means finding the square root of the value calculated from the previous step. Find the square root of root 1, use the syntax root 1 dot square root. Update the value of root 1 to the square root. Square root is a built-in Swift method that you have access to. Methods will be covered in, so let's do spending a little more on the broken up formula. This time root 1's new value will be negative b plus its current value. To finally solve for root 1, review the complete formula. It's not how I wanted to spend my time. It's fine though, they're not gonna let me go on to the next one until I do this. Root 1 divided by 2 times a. For root 2, it's almost identical except the equation has a minus sign. I don't know if it's gonna let me do that, so I'm not gonna try to. So let's output these 2 roots using print. Run the program using the terminal. Suppose that should be that, or try. Did you get the correct roots? Yeah. I didn't even need to do that. Whatever. Whatever. At least it's good practice, right? Creating a new project in XCode. Let's go. In this article, you will learn how to create a new project in XCode with Swift UI and gain an understanding of different components of XCode. At this point, you have downloaded XCode and learned a little bit about Swift UI. I've also prepared the wireframes for the trivia game app you're going to build. In this article, you'll learn how to work with XCode to start bringing that app to life. You'll also gain an understanding of the different parts of XCode that you'd use frequently as you build the app. First, go ahead and open XCode. So let's make this half the screen. Let's close that for now. Let's come here. So learn how to work with Xcode. So open it. You should see the following interface. Create new project, clone, Git repository, open existing project. You'll be presented with 3 options. The clone an existing project option is used to copy code from a remote repository on the internet using Git. While you won't need to use Git for the skill path, you can learn more about it at the course here. What is that? Oh, no, I'm good. Once you start working on different projects, you can use the open a project or file option to open an existing Xcode project on your Mac. For this path, you'll need to create a new project in order to build a new iOS app. So go ahead and select create a new project. Whoa. Okay. Next, you'll be asked to choose a template for your project. Choosing a template platform. At the top of the window, you'll see the options multi-platform. Put it right there. Multi-platform, iOS, macOS, watchOS, tvOS, and other. We would select multi-platform for our app if we'd like it to be available on multiple platforms like iOS and macOS. We choose iOS, macOS, tvOS, or watchOS if our app is exclusive to any of these platforms. Since we're creating an app for iPhones, select iOS. Application and frameworks. Under application, you'll see the following options. App, this is the option to choose for most standard apps. Creates a project with a single user interface or view. Document app, choose this option if you expect your app to create documents and share them with other apps. Examples of such apps are text editors and spreadsheets that incorporate a file browser. Game, choose this option if you want to create a gaming app that requires complex graphics. Even though we're building a game in this skill path, our app doesn't require advanced graphics features to be able to run, so we won't choose this option. Augmented reality app, select this option to create an augmented reality app. So now there's an app playground, but back when this was made, there wasn't, so I'm guessing. So sticker pack app, choose this option to create a project with stickers to be used in the iMessage app. Note that sticker packs are extensions and not apps and can only be used with iMessage. iMessage app, this option is used for projects that allow you to create extensions for iMessage or standalone iMessage apps. You can choose to create a framework or library that can be used by different apps with Xcode. You can create a framework, a static library, or a metal library. Audio unit extension apps, Safari extension app. Options, since we'll be building a basic iOS application, go ahead and select app and click next. In this next screen, you'll provide all the information pertaining to your project and configure your application. Product name. This field should hold the name of the app you're building. The app we built in this path is called Code History, thus that's the name you should add. Now, if you plan to publish your app to the App Store, make sure to use a different name, as there will most likely be another app by the same name on the App Store already, in which case Apple's developers will reject your app. Team, you can leave this as none for now. You need to specify the team name if you want to upload your app to the App Store. Organization identifier, a reverse DNS string that uniquely identifies your organization. For example, if the name of your organization is XYZ, then the reverse DNS notation would become com.xyz. However, since you're building this app for yourself, you can use com.yourname. So we'll do com.gorogers. You may need to revisit this step before uploading your app to the App Store. Bundle identifier. This field is pre-filed based on the product name and organization identifier you've provided. The bundle identifier uniquely identifies your app in Apple's ecosystem, implying that no two apps can have the same bundle identifier. Interface, you have the option to choose between SwiftUI and Storyboard. Storyboards are used to graphically lay out UI elements in the app. They're used only with UIKit, thus we won't be using them in this skill path. Select SwiftUI. Lifecycle, I guess that's an outdated thing. Lifecycle, select the SwiftUI app. The other option is UI, blah, blah, blah. Language, select Swift. Since you selected SwiftUI as the interface, there's no choice but to choose Swift in this case. You can also build iOS apps using the Objective-C language, but it only works with UIKit. Use Core Data. Core Data is used to build and manage the data layer. So wait, leave this option unchecked. Got you. We won't be using this feature for our app. Core data is used to build and manage the data layer in iOS apps. Include tests, leave this option unchecked. In general, it is a good idea to write tests for your code, but we won't be covering that in this article. Click on next. Gotta save it somewhere. Choose the location where you'd want this project to be created and live on your machine. We won't be using Git for this project, so leave the source control box unchecked. Leave other options unchanged. So let's go ahead and documents. Let's do a new folder, XCode. Save it there. Explore Xcode. Cool. So now that the project has been created, you'll see the following workspace window. The iPhone simulator is still loading. The workspace window, also known as the main window, has different sections containing all the resources you need to build your app. Let's go over the sections highlighted in the figure above. Toolbar. Toolbars were up at the top. Consists of controls to build and run the app. View the progress of running tasks. Choose the run environment, simulator/device. And add new UI components. Navigator area allows you to access different parts of the project easily. All the files in the project are listed here. You'll notice that the navigator area has a few icons. By default, the file navigator is open. So here we see the file navigator. There's also some other stuff. Your repositories, bookmarks, search. What's this? Something. Code history auto-created. Debug. Breakpoints. Something. Local and cloud. So, by default, the file navigator is open, which allows you to view all the files in the project. You can click on the Find Navigator icon indicated by the magnifying glass and search for text/code in the project, or click on the Issue Navigator icon, presented as a triangle with an enclosed exclamation mark, to see whether your code has any warnings or errors. You can click on the error or warning to navigate directly to the code where the problem has occurred. Editor area. This area can be divided into two parts: a code editor and preview. On your left is the code editor, this stuff, where you write and edit your code, and on the right you have the preview area that reflects the changes you make in the code editor in real time. So if I change this to Hi World, it's cool. On a specific iOS device, you may have noticed that a few files are automatically generated when you created the project. One of these files is contentview.swift, which already contains a few lines of code when you open it for the first time. This default code contains a text component that prints hello world on the screen that you see in the images. You'll get to dive into the code in a later section. Note the preview area is visible only when you're building UI components. Inspector area. This area gives you information about the file that is currently selected in the navigator area. So text Hi World, accessibility, label, inherited identifier, font, inherited, weight, inherited, color, inherited, alignment, line limit, padding, frame. Lets you change attributes of the file as well as its constituent components. For example, you can change the font and color attributes of the text hello world from the inspector area as shown below. So we could do red. How come I'm not seeing a difference though? Oh, now I do. And it adds this dot foreground color, color.red. Change it back to inherited. That goes away. For example, Okay, yeah, I read that. Changes made from the inspector area are automatically reflected in the code block. Run your app. To run your app, we utilize the toolbar. Let's take a closer look at its components. The play button, denoted by the triangle, is used to run the app. The app can be stopped using the stop button to the right of it. Following the app name, code history, you see the type of device on which the app is being run. In this case, the device is an iPhone 12 mini simulator running iOS 14.3. Click on it to see a list with other simulator options and select a desired device. Once you've selected your device, click on the play button to run the app. This runs it in this simulator. This might take a while because it's the first time I'm ever using it. As the app launches, you'll see a new section open up just below the editor area. Known as the debug area, this section, now it's coming. This section outputs any errors caused at runtime due to logical errors that aren't caught while building the app. It also shows warnings that convey things that may be wrong with your code. Additionally, here you can debug your program and inspect the values of different variables. You can show the debug area with Shift Command C and hide it with Shift Command Y. So Shift Command Y, Shift Command C. Take a closer look at the toolbar. When you've run the app, in the middle of the toolbar lies the activity viewer. Where XCode displays messages about the build process, attaching to code history on iPhone 15 Pro. The messages appear in the following order: building code history, planning build, attaching to code history on iPhone 12 mini, launching code history. The attaching to code history message may appear after the launch message as well. Finally, when you press the stop button to close the app, the toolbar shows the following message: finished running code history on iPhone 12 mini. Once the app is built successfully, your simulator should have launched and shown the following screen. You can choose to run the app on a physical iPhone as well. However, some additional settings need to be configured on XCode to run an app on an actual device, which we shall cover in upcoming articles. Project settings. Click on the code history project. So let's come back here, end it. So wants me to click on this. This opens the project settings panel. Under the general tab, you'll see some familiar field names like display name, the app name. Or am I supposed to see that? It's a little bit different. So under the general tab, display name, bundle identifier, unique identifier of the app. The other settings include the deployment target of your app, which is the minimum iOS version on which your app can run. Which your app can run, the types of devices it can run on, such as iPhone, iPad, or Mac, and the device orientations you like to support, including portrait, landscape left, landscape right, and upside down. There are many more settings that can be configured from this panel, which you'll explore more of as you work in XCode and build your app. Wrap up. Congrats as you create more projects and work on multiple apps. You'll feel more comfortable with the terminologies of components in Xcode. In the next article, you'll learn more about the files in the navigator area and take a closer look at the code they contain. Navigating the file structure in Xcode. Explore the files that live in the navigator area of Xcode. Previously, we've explored the main Xcode window and learned about the different areas like the navigator, editor, and debug area. We've seen that the navigator area consists of sub-navigators like the project navigator, which holds all of our project's files and folders, and the issue navigator, which alerts us of any errors and warnings. In this article, we'll look exclusively at the project navigator. The leftmost tab that lists all of the files included in the project. We saw in the last article that Xcode generated some files automatically. When we created the project, let's take a closer look at these files and understand what they do. The .xcode proj file. Let's first begin with the topmost file named code history. Right click on it and select show in Finder. See it here. Finder window should appear with the code history.xcode proj file highlighted. Not exactly, but close enough. The Xcode proj is actually a directory, but is represented here as a single file that contains configuration settings for the app. These settings are used to update information about the app or to look up certain details before submitting the app to the App Store. As shown in the image above, we can modify a number of things in the project settings, including the name of the app, the version number, device type the app supports, deployment type, code history app.swift. The next file on the list is code history app.swift. It contains a struct that conforms to the app protocol. We'll look at what a struct or structure is later in the skill path. You can learn more about protocols in Apple's official documentation. For now, think of app as something that represents the structure and behavior of the app. The main attribute at the top of code history app struct denotes that this is the entry point for the app. This is the first .swift file to be processed when the app is run. In UI kit-based apps, the entry point is handled by the app delegate class. We can still choose to create Swift UI apps using app delegate, but using the app protocol is the latest and shortest approach. Note that the variable body inside the code history app structure contains content view. That's the next view we'll talk about. Content view.swift. Content view.swift contains the content view struct. This file is automatically generated along with the code history app.swift. By default, content view acts as the landing page of the app, meaning this is the first user interface we see when we launch the app. Xcode makes sure that content view isn't empty when it is generated and adds a hello world text to it as shown in the following image. Note that the editor area and the utilities area are both updated automatically when we switch between files on the navigator area. Furthermore, you'll notice changes in the utilities area when you select different UI components in the editor area. Below the content view, first of all, let me just hide this. Below the content view lies the content view preview structure right here, which conforms to the preview provider protocol. Content view previews generates the preview that we see on the right hand side of the editor area. Previews are meant to allow the developer to visualize how the UI would look as the code changes. Previews are often created using sample data, and there can be multiple previews for a single view. Assets.xAssets, the assets catalog, allows us to add static images to the app. It includes a specific category for the different icons the app would need before it is uploaded to the App Store. In the image above, you can see the different icon sizes required for both iPhone and iPad versions of the app. Since we're building this app for the iPhone, uncheck the iPad option in the utilities area. I don't see that option. Recently, Apple has added an accent color category to the asset catalog. Think of accent color as the theme color of the app. Certain UI components like buttons acquire the accent color when they're rendered on the screen. Xcode allows us to specify the accent color for the app directly in the assets catalog. However, instead of images, we have to specify colors in this case. We may choose to leave it blank, in which case the app will utilize default accent colors. Info.plst or information property list files are structured text files that contain key value pairs to identify a bundle. A key value pair is a pair of data elements where the key represents the type of data the pair represents, and the value is the variable of that type, e.g. fruit equals apple is a key value pair. Note, newer versions of Xcode have moved the contents of this file to a different location. Don't worry if you don't see it. In Apple's parlance, a bundle is used to represent apps, frameworks, plugins, and many specific types of content. The info.plst file is also automatically generated when the app is created and contains some basic information such as the product name and bundle identifier. Preview content. The preview content folder and the preview assets xassets preview assets catalog are meant to contain sample data for the previews. As mentioned earlier, previews serve to provide instant feedback to the developer as they make changes to the UI code. While it is totally possible to create previews with minimal data, sometimes it is better to have different data samples to test the UI more effectively. Such sample datasets may be included in the preview assets.xcassets catalog products folder. The products folder contains the .app file, which is an executable version of the app that can run on a simulator or a device. For the code history app, this file is named code history.app. Wrap up, congratulations. You now have a good idea of the different files and folders that are generated when you create a project in Xcode. As you build the code history app, you'll interact with the project navigator regularly. Hence, it is important to familiarize yourself with this section of Xcode. Later in the skill path, you'll create your own files, which shall also appear in the project navigator. Up next, you'll learn about conditionals in Swift. So, full screen this again. On a daily basis, we're faced with making decisions based on certain conditions. All right, I get it. If statement. What do I gotta do? In Learn to Code Swift, we'll create an if statement that prints a message for you. First, declare a variable learn to code. On the following line, set up an if statement. So if, how we do this? So if condition, so if learning to code. Within the if statement, print. Don't forget to take breaks. You got this. Do I have to end it with? No. Cool. No semicolons. Reassign the value of learning to code to false after the initial variable declaration before the if statement. Else statement, a tool most commonly used, so same idea. In classes.swift, we'll create an if else that prints an emoji representing you. First, declare a variable, so var, wear glasses. What is it? Assign a Boolean value of true or false, or I don't, so false. Below wear glasses, create an if else statement. So if wear glasses, print I wear glasses, else print I don't wear glasses. What'd I do wrong? Did I misspell something? Did you add a print I don't wear glasses statement? Comparison operators. Okay. Set up an if-else statement. So if tune, what a movie. Tune squad points. Checks if it's less than Monstars points. Using the correct comparison operator within the body of your if statement, print a message for the winning team. Add an else statement within the body of your else statement, print a message for the other winning team. Else if statements until now. Okay, cool. Got it. We'll write a program that translates the abbreviation of languages spoken in New York. First, Google 4 languages spoken in New York and their abbreviations. Store each language name and abbreviation in a multi-line comment at the top. So what'd I do? Did my thing die? Oh no, cool. We'll do English, EN, and we'll do Spanish, and we'll do I don't know, French, and we'll do Chinese. What is that? CH? Cool. So following the multi-line comment, declare variable abbreviation, and assign it to one of the language abbreviations. Oh yeah. Create an if-else statement that contains 3 if-else statements. So if this, else if, else if, else if. Checking for the different values of abbreviation. The if and else if statement should check if abbreviation is equal to something. So if contain a print statement with the corresponding language. Else statement. Prints the message. Ternary conditional operator. Question mark and a colon. Cool. In Sailing Swift, we've set up an if-else statement that checks for windiness on the following line. Rewrite the conditional in ternary format. So switch statement. So we're doing switch city, case Rapa Nui, print Moai, case New York, print Statue of Liberty, case Rome, print Colosseum, default, print a famous landmark is the Eiffel Tower. So in superheroes.swift, we have a series of else if statements that match a superhero's secret identity to their superhero name. We write this conditional in switch statement format. So switch secret identity case Tony Stark, print Iron Man, that. In superheroes.swift, we have a series of else if statements that match a superhero's secret identity to their superhero name. We write this conditional in switch statement format. So we'll do it like this. Prince T'Challa. I am the Black Panther. Wakanda forever. Superhero name Black Panther. Such a good movie. Thor actually, you know what? Did they make a Black Widow movie? I don't know, but the Iron Man movie, the Black Panther movie, and the Thor movie, not Thor 1. Thor 1 was trash, but Thor Ragnarok, man, superhero movies can be really good when they're good. They can be really bad when they're bad, but Thor Ragnarok, Iron Man 1, and Black Panther, so good. So anyway, Thor, so case, Thor. And I realized I messed up on the Prince T'Challa thing. So it's this. This is annoyingly long. Superhero name equals Thor. And then default. Unknown. No, I messed something up. Did you assign the string unknown? Oh yeah, I didn't. Cool. Following the switch statement, print superhero name. Goodness. I'm trying to move too fast, huh? Print superhero on. I could 31. I think I tried to run it before I was even done typing it. So, switch statement interval matching. One superpower that the switch statement possesses is its ability to match values to an expression that exists within intervals. An interval denotes a range used for checking whether a given value lies within that range. In Swift, a range is indicated by 3 consecutive dots, ... also known as the closed range operator. The closed range operator signifies an inclusive range where the first and last values are included in the sequence. Let's see these new concepts in action. In the example below, the switch statement determines the value of a year and checks which century it belongs to. So var year equals 1943, switch year, case 1701, ... 1800, print 18th century, and so on. Since the year 1943 falls between the interval 1901, ... 2000, the code for the third case is executed and the message 20th century gets printed. Fun fact, the first electronic computer was built in 1943. In Star Wars villains.swift, we'll create a switch statement that determines the villain in a Star Wars episode. we've declared and initialized two variables that will be used throughout our switch statement. So var episode 8, or var episode equals 8, and var villain is a string. First, create a switch statement that accepts episode as its expression. So they really picked episode 8, which actually might have been the best one out of the three newest trilogies. Regardless, switch episode as its expression. Keep the body of the switch statement empty for now. You'll see an error in the terminal, but it will go away. Within your brackets of your switch statement, create case intervals using the following information. So case 1 to 3. Default after the switch statement, print villain. Continue practicing in the editor by testing your code with different values for episode, whatever. Switch statement compound cases. Another noteworthy ability of the switch statement is its use of multiple values in a single case. These are known as compound cases. The switch statement will match each value within a compound case to the given expression. The following code checks the value of country and determines the continent on which it is located using a switch statement. Since a continent may consist of multiple countries, compound cases deem useful. So var country equals India, switch country, case USA, Mexico, Canada, print country is in North America, and so on. Notice how the multiple values or items in a compound case are separated by a comma. We used string interpolation to output the value of country within the string of the print statement. So I can already tell it's gonna be a lot. So I'm gonna go ahead and copy this and edit it. The 8 planets within our solar system are often categorized as terrestrial or Jovian planets. In planets.swift, we'll set up a switch statement that utilizes compound cases to determine the type of planet it's given. First, create a switch statement that accepts planet as an expression. Keep the body empty for now, so I'm just comment this out. Maybe I won't just write over it, but I'll use it to draw from. So we'll do switch planet. Use the following information to set up the case statements within the switch. So case these are the breaks. So these are terrestrial planet. I'm printing, right? So print following the terrestrial planet. Goodness. I think it's gonna be mad at me for doing this. I don't think it wants me to do what I'm doing, but I'm doing it. I could delete it later if it doesn't want me to do this. It's a Jovian planet. Yeah, I know. Continue practicing. Got you. Switch statement where clause. Another neat feature available for the cases of a switch statement is the where clause. The where clause allows for additional pattern matching for a given expression. It can also be used with loops and other conditionals such as if statements. Assume we're creating a program that determines if a random integer between 0 and 10 is even or odd. We can write the following program. Var random number equals int.random in 0.10. So it's going to create a random number, a random integer between 0 and 10, switch random number, case let x where x modulo 2 is equal to 0, print random number is even, case let x where x modulo 2 is equal to 1, print random number is odd, default print invalid. Let's dive into what's happening on the first line. We're generating a random integer int using the built-in Swift method .random, which returns an arbitrary value from a range of numbers. Notice how we're using the closed range operator to denote a numerical range. We then assign the randomly generated value to the variable random number. We'll be working more with .random in the following lessons. Following the variable declaration is a standard switch statement that checks the value of random number. Switch random number, case let x where x modulo 2 is equal to 0, print random number is even, and so on. Each case contains a variable declaration followed by a where clause and a condition. When a condition is true, the code for that case will execute. The let keyword followed by the x creates a temporary binding to the random number value. This means that the value of x temporarily becomes the value of random number. If random number is 5, then x is 5. Again, the let keyword followed by the x creates a temporary binding to the random number value. This means that the value of x temporarily becomes the value of random number. If random number is 5, then x is 5. The let keyword is specifically used here instead of var, since the value of x will not be reassigned at any point throughout the switch statement, thus its value will always be constant. If var is used, Swift will display a compiler warning recommending us to use let instead. Number Swift 612 warning, variable x was never mutated. Consider changing to let constant. Note, a compiler warning is not an error. Your program should still run even with a warning. Lastly, the where condition checks if x is divisible by 2 with or without a remainder and determines if the random number is even or odd. If you run this code, chances are your output will be different from ours since the number generated each time is random. Okay, so in numbers.swift, we'll set up a program that determines if a number between 10 and 20 is prime or composite. Below the whole number variable, set up a switch statement that accepts whole number as its expression. Keep the body of the switch statement empty for now. Within the code block of the switch statement, set up the following cases. So case 1, declare the temporary variable x. So let x, what is it again? So let x where x divisible by 2 modulo 2 is equal to 0. Print composite. Declare the temporary variable x and use the where clause to check if the value is divisible by 3. Composite. The default statement. Print prime. Awesome work. This step is optional, so feel free to hit run. Review. Excellent work. In this lesson, we've learned the following concepts. An if statement consists of a condition and code block that executes when the condition is true. Alright, gotcha. Got it all. A switch statement looks for the value of a case that matches the value of an expression. A switch statement can have cases that contain multiple items, known as compound cases. A switch statement's case can include a range of values using the closed range operator ... You've covered a major fundamental programming concept used in every program to control the logic flow. Feel free to utilize the empty review.swift file and output terminal on the right to hone your understanding. No, thank you. What's up next? Select the correct syntax for a Swift interval. Which of the following Boolean expressions results in false? If Swift is not equal to Swift, code academy is equal to code academy. Assign the correct value for birthday. For birthday equals, so if birthday, print celebrate. Print celebrate. So what will be the value of a year created after the following switch statement executes? So var programming language equals Ruby. Let year created int. Switch programming language. Case Ruby. Created 1995. Complete the switch statement and its output. Let dev role equals app developer. Switch dev role. App developer will print a phone. Which of the following messages will print to the terminal after the switch statement executes? Let number equal 24. Switch number. Case let x where x modulo 5 is equal to 0. So this number is a multiple of 5. Case let x where x modulo 6 is equal to 0. Print this number is a multiple of 2, 3, and 6. So in the case of 24, that one will print. Case let x where x modulo 7 is equal to 0. This number is a multiple of 7. Default, not sure about this one. So it will be this number is a multiple of 2, 3, and 6. Select the correct output for the following code. Var wireless headphones equals false. Var connection string. If wireless headphones connection equals Bluetooth, else connection equals lightning. And place the items in the correct order to complete the ternary conditional. Var low on gas equals true. So low on gas. If so, print find the nearest. Otherwise, keep driving. Nice, nice, nice. So now it wants me to build iOS apps with Swift. A Magic 8 Ball is a popular toy developed in the 1950s for fortune telling or advice seeking. In this project, you'll hone your conditional skills by creating a program that can answer any yes or no question with a different fortune each time. So, unfortunately, I mean, I don't feel like doing that. Even though I'm at the thing, I don't know. Maybe I will do it later. Maybe I won't. I don't know. Regardless, I'm pretty much at the end of my time. I only wanted to go to 3. And doing this is going to put me over that. So, a little bit convenient. So, I don't really want to do it. I guess I'll go till 3. And then if I don't finish it, I'll just stop. So, declare a constant named player name. Assign it to my name. Geo. The second constant we'll need is player question. Declare it on the following line and assign it a yes or no. Question you like to player question equals am I cool yet? Let's do that. Next, we'll need a constant to store a randomly generated value. Declare the constant random number. So let random number and assign it the result of calling .random on a range of ints 1 through 8. So random number equals int .random number 1 through 9. I think that's how you do it. We'll find out. Print the value of random number to ensure the random values are being generated as expected. Running the program several times will result in different. Okay, I didn't get it right. Type int has no member random number. Nice. Lastly, declare the constant 8 ball. Control flow. Now that we've completed our constant declarations, it's time to develop the core logic of our program. Create a switch that accepts random number. Contains 9 cases. Damn. So each case will check for one numerical value between 1 and 9. For example, if random number is 1, the first case 1 will execute. So case 1, case 2, case 3, case 4, 5, 6, 7, 8, 9. Each case should assign an answer to 8 ball. So yes, definitely. It's decidedly so. Damn, Outlook not so good is gonna hurt. Let's see. Let's do this. Without a doubt. Reply hazy. Try again. Ask again later. Recently, my little cousin was up here from the Bahamas, and we went to the Museum of Science. And you think you're in Boston. We got MIT here. We got like Harvard and stuff. You'd think that the Museum of Science here would be pretty cool. It's pretty whack. The only cool thing was that you could see a Boston Dynamics spot dog, like when you first walk in, which was pretty exciting, but got my hopes up way too high. Long story short, though, at the end of it, I didn't want to go to the museum store, but my sister did, and he bought like this. It wasn't an 8 ball, but it was like a guessing game type of thing with like a ball and a magnet in the middle, and you're supposed to let the ball go. The ball's on a string, and the magnet is supposed to put it to an answer, and each time it would just say ask again or no or some shit. It was like stupid. I was like, y'all spent $20-$30 on this for no reason. Conclude the switch statement with a default statement that will assign the string error to 8 ball. So default see the magic now. Let's see our magical oracle in action. Add a print that will output the player's name followed by the question. So player name asks player question. Okay, add a second print statement that will output the magic 8 balls answer, which will be magic 8 balls answer, and 8 ball. It is decidedly so. Let's go. Optional challenges. I'm pretty much at time, so I guess I'll just leave it there. Why not? I mean, that's a good place to end it. So peace. I'm gonna catch up with this